Question number 11 on page 233 it has a problem based on saving money in a bank, and it says a bank pays you interest and the interest compounds. So this problem is part of a general bigger problem that we call exponential growth problems. And exponential growth problems follow this pattern that I've shaded in the green here. The general formula for exponential growth is end equals start. The ending amount is equal to the starting amount times the growth factor. So we multiply by the growth factor, and then we apply that growth factor the number of growth cycles. So however many times we apply the growth factor is represented by the number of growth cycles. So in this problem here, it says that we end up with $3,000. So notice in the blue that we have $3,000 as the end amount. We're trying to find out the starting amount. The growth factor is based on the interest of 2.5%. So we put our growth factor as 100% plus the 2.5% we earn, which is 0.025. And then the growth cycles represents the number of years that we apply this. We applied this percentage every year for 5 years, and we're going to end up with $3,000. So this question basically is just asking us to find the start. And if I rearrange the equation, I'm going to end up with the one down here in green. And really the question is just asking us to calculate the amount, do the calculation that's shown here. But to get there from the exponential growth problem, we just want to get rid of this times by 1.025 to the power of 5, so we divide both sides. So this starting amount can be calculated in the green here. It's the same as a p. And to make it look exactly the same, that exponential expression in the denominator, because it's in the denominator, we just make it a negative exponent, and then it's the same thing. So this here will calculate the same thing, but this is how we get to the same equation that we have here. So basically, we just need to calculate this value, and the value works out to be $2,651.56. So this question is fairly straightforward in that all it's really asking you to do is to do this calculation, but it is part of a larger problem of our larger set of problems which deal with exponential growth, and we use this equation up here to deal with exponential growth problems.